Hi, my name is Caroline Griffin. I'm a student in ENME351 Section 0101, and I'm in Bay 2. This is my Lab 5. So this is my setup. Right now I have a 10 kilo ohm resistor in. So looking at my Arduino code, in my setup I declare pin 9 as an output, set it to low, and then delay that for 5 seconds. My serial monitor is reading at a rate of 115200 bits per second. In my loop, I declare my resistance, and right now it's at 10 kilo ohms. My capacitance is also 10 microfarads, and then I multiply them together to get my time constant. So for the first loop, I do a for loop, going through it at 500 iterations, and it's going to be delayed tau over 50, and when you multiply those together, you'll get 10 times tau. So first I do a digital write pin 9 high, and then I read in the voltages going into the circuit and then after the resistor. And then I string these to the serial monitor and delay at tau over 50. And note I didn't change my resistance and capacitance to ohms or farads because I wanted them in milliseconds for the delay. Then for my second loop, I do the same thing, again 500 iterations at tau over 50, and I digital write pin 9 to low, and then read in V in and V out, string the voltages again, and delay by tau over 50. So if you run this, the serial monitor will show the voltages switching from low to high, and then V out is changing respectively. For my processing code, all I did was change the baud rate from 9600, and then down here within the if statement, I figured out where my line should be for 5 volts, 4 volts, 3 volts, all the way down to 0 volts. And for the 4 volts, for example, I did 4 volts over the full scale range. And so 4 over 5 times 1024 is a code of 819.2. And down here, it takes in the voltage values and divides by 2. So I had to do the same right here. And then to plot it, it does an ellipse of 550 minus that number. So I had to do 550 minus 409.6, and then I got where my Y value should be on the window. And so I did that for each of the voltages. And then to make the legend, I did a fill. I just made a dot, an ellipse on the screen, and then I put V in next to it, and then the same thing for V out. So if we run this, you'll see the chart. I just let it go through a couple times and then I stop it. For MATLAB, the only thing that you have to make sure of is that the resistance is 10 kilo ohms, which it is. And then change whatever the data file is. And here's my chart. And this whole thing is 10 tau, which is 1 second, so tau would be 0.1, which you can check by multiplying R times C. I'm now doing this for 100 kilo ohms, so I changed out the resistor. In my Arduino code, I just made sure that R is now 100, but the code stays the same. And I upload it, and then run the processing code. You're going to see, so it's taking longer to get to the peak voltage. I'll just let it run for a couple times. MATLAB, make sure that the resistance again is 100 kilo ohms. Change the file name and run. So there's the chart. Again, the tau is 1, and then 10 tau is going to be 10 seconds. And you just see that it takes a little bit longer, which also matches up with this code. For the 10 kilo ohm, it takes faster to get to the max voltage versus 100 kilo ohms, it takes a little bit longer.